Chapter 1, Section 1, Variables and Expressions. An algebraic expression is a mathematical phrase that uses one or more variables. A variable is a symbol, usually a letter that represents a value. The most common letter that's used as a variable in math is x. Solve for x, solve for y sometimes, but any letter can be a variable. A numeric expression is a mathematical phrase involving numbers and operation symbols, but no variables. So an example of a numeric expression would be 8 divided by 2. The operation is division. Our operations are addition, subtraction, multiplication, and division. But there is no variable. It's only numbers and operation symbols. Some words that would indicate addition would be sum, plus, total, more than, or increased by. Some words that would indicate subtraction are difference, minus, less than, or decreased by. Some words that would indicate multiplication are product, times, multiplied by, and of. And words that would indicate division are quotient and divided by. We're going to use these words to translate between words and expressions. The first set of examples says, what is an algebraic expression for each word phrase? The first example, A, says 25 more than a number n. More than indicates that we are going to be adding. We're adding 25 and the number n. So that could be n plus 25. Now, addition order does not matter. So n plus 25 is the same thing as 25 plus n. Both are correct. But when we look at example B, it says 74 less than a number n. Less than indicates that we are going to be subtracting. If you read this carefully, 74 less than a number n, you can tell that we're going to have the number n and we need 74 less than that. So the order is n minus 74. The easiest way to remember this is that when you see less than, you're always going to want to subtract the first number, in this case it's 74, from the second number, so when this case is n. So kind of flip the way that they appear, and that's how you're going to subtract. If you notice, 74 appeared first and then n is last, so we flopped them so that n is first and we're subtracting 74 from that. The next example says, what is an algebraic expression for each word phrase? Example A says 5 times a number n. Times indicates multiplication. We can show multiplication by a number and a variable by simply writing them next to each other. So 5 times the number n can be written as 5n. Example B says the quotient of a number n and 7. Quotient indicates that we are going to be dividing. When we see, and again, just like in subtraction, division, the order does matter. When we see quotient, we're going to keep the order in which they appear the same. So the quotient of a number n and 7, we're going to keep n first, and then we're going to divide by 7. The next example says, what is an algebraic expression for each word phrase? A says 4 more than twice a number x. More than indicates that we are going to be adding. Twice a number x, if we are to have twice of something, or 2 times as many, we're going to multiply by 2. This algebraic expression looks like 2x plus 4. Twice the number x, 2x, and 4 more than that, so we add 4. B says 7 less than the quotient of 8 and a number x. The quotient of 8 and a number x means that we're going to have 8 divided by x, and then 7 less than that. Remember, less than order does matter. We're going to flip the order, so it's going to be 8 times x, and then we subtract by 7 at the end. Example C says the product of 9 and the sum of a number x and 2. Product means that we're going to be multiplying the product of 9, and it's multiplying 9 and the sum of a number x and 2. So we're actually multiplying an addition problem by 9. The addition problem needs to be in parentheses, so the sum of a number x and 2 is in parentheses, and then we're multiplying that by 9. The next example says, what word phrase can you use to represent the algebraic expression 4x? 3 examples. We could say the product of 4 and a number x. We could say 4 times a number x. Or we could say 4 multiplied by a number x. Writing an expression to describe a pattern. The table shows how the cost of renting a scooter depends on how long the scooter is rented. What is a rule for the total cost? Give the rule in words and as an algebraic expression. The first thing that we look at is we're looking to see what you can do to the number of hours, h, to get the cost. So if you look at the table, we're looking at the first column. Under hours, we have 1, 2, 3, 4, 5. What can we do to those numbers to get the corresponding cost? So what can we do to 1 to get $17.50? What can we do to 2, and it's the same thing? What can we do to 2 to get 25? What could we do to 3 to get $32.50, and so on? The first and easiest things to check before you move on is check to see if you are just adding or subtracting. So what would you need to add to 1 to get $17.50? You would need to add 16.5. Well, 2 plus 16.5 is not going to give you 25, so that is not going to work. The next and pretty quick thing to check would be to check to see if you can just multiply or divide by something. So to go from 1 to 17.5, we would multiply by 17.5. We'll test it for 2. 2 times 17.5 is not going to give you 25. When we've checked to see if we can just add or subtract or just multiply or divide, and in this case, neither one of those has worked, so we know that we're going to have more than one operation. So in this case, we're going to be performing 2 operations, which means we're going to be multiplying or dividing and adding or subtracting to h, the number of hours. This is kind of a guess and check process. You might look for the pattern and see if you can tell which combination of multiplying or dividing and adding or subtracting will work. Once you've figured it out, it should be 7.5h plus 10. In words, you would say multiply h, the number of hours, by 7.5 and add 10. This rule should work, or to be correct, it has to work for all of the combination of hours and cost. So when you plug in 1, you'll get $17.50. When you plug in 2, you'll get $25. When you plug in 3, you'll get $32.5, and so on. The homework for tonight, or today's assignment, is page 7, numbers 11 through 37 odd, number 39, and number 45.